Good evening, Rizwana. Good evening, everyone.
Good evening, sir.
Good evening, sir.
Give me 1 minute. We'll continue with electricity.
Good evening, sir.
Good evening.
Good evening. Good evening. So, in the last class, I think we had completed with series and parallel combinations.
Yes,
Okay. Did we do anything about electric power? I don't think. Okay. So I think we shall continue with electric power today. So today we see electrical energy and electric power. Right?
Good evening, sir.
Good evening. Okay, so let's see electrical energy and electric power. So when electrical energy or current flows through a wire, the electrical energy is converted to different other forms of energy. So when the electrical energy or current flows through a resistor or any other device, which we generally call as the load, so either it causes heating effect, or it causes the emission of light, or it causes the other aspects also. So for electrical energy and electrical power, suppose if you have a resistance here, so you have a resistance R, and when electric current I passes through it, then here across the resistance, since the resistance is opposing the flow of charges, okay, and therefore the charges need to do some amount of work, okay, and that work done by the charges or work done by the electric current here, it appears in the form of heat energy across the resistance. So we can say, obtain the amount of electrical energy using different formulas. We can also state it using Joule's law of heating. Okay. But before going to the Joule's law of heating, we'll try to establish a relationship between electrical energy, current, and voltage. Okay. So suppose you are using a resistance which is maintained by a potential difference of V volt, right? And current I is flowing through this resistance. So you can find out here. You can find out the amount of work done by the charges. So work done per unit charge is given as electric potential V. Therefore, work done will be equal to Q into V. I think everyone should agree with this statement that the work done by the charges will be given as Q multiply V. Is it clear to everyone? Dharya?
Yes, sir.
Subhansh?
Yes,
Dharya,
sir.
are you there?
yes, sir, it's clear.
Okay.
Yes, sir.
So now, but here we are not talking of in terms of charges. We are talking in terms of current. Okay. And we know that charge divided by time is current. So we can write it as W equals to Q times V divided by T multiplied by T. Can we write like this? I can multiply this whole by 1. So I have divided it by time and I have multiplied it by time. So time and time will get cancelled. It will remain 1 only. But see, Q over T, that is rate of flow of charge. Q over T is current. So I get the formula of work done to be V times I times T. Am I correct here? See, the amount of work done by the charges in when a current I flows through a resistance for a time T, then the work done is given by VIT. Is it correct?
Yes, sir.
Okay. So from this formula, I can obtain different other relations. From this one, we can obtain different other relations also. Like using the Ohm's law. As we know that, as per the Ohm's law, we know electric potential V will be equal to IR. Alright. So I can substitute the value of electric potential. So substitute the value of electric potential and see what do you get.
I square RT.
I square RT. Alright. So you get another formula for the heat energy that will be developed. I can also call it to be the heat energy. Right? Since the amount of work done is the same as the energy, so I can write down amount of heat energy will be equal to VIT. I can also write amount of heat energy is I squared RT. This second statement which we have obtained is also called as Joule's law of heating. It is also called Joule's law. So according to the Joule's law, the heat produced across a resistor is directly proportional to the square of current to see. According to the Ohm's law, the heat produced across a resistor is directly proportional to the square of current, is directly proportional to the square of current, directly proportional, you can say here it is directly proportional to the resistance and directly proportional to time. So this forms the statement of the Joule's law of heat. Sorry, by mistake, I think I have written here Ohm's law, but this is Joule's law, not Ohm's law. Don't confuse it with the Ohm's law. This is Joule's law of heating. So you can read it as according to the Joule's law, the heat produced across a resistor is directly proportional to the square of current, directly proportional to resistance, and directly proportional to time. Got it?
Yes, sir.
Now, using the Ohm's law, we can obtain another variation for this. See what we can obtain. I can use the formula of current from the Ohm's law only. I know that V is equal to IR. So I will get the value of current as V over R to be I. If I use this relationship here, use the value of I to be V over R, so I get heat produced will be equal to V squared over R squared times R times T. So here the R and R gets cancelled. Therefore, you get V squared by R times T. This is Joule's law of heating. So not Joule's law. Amount of heat that will be produced can be given by any of the three formulas.
Sir, this is called Joule's law of heating, right?
Joule's law of heating is I square RT.
Oh, okay. Okay, sir.
Okay. So now let's have a quick idea what all we have done. Amount we have got here, the amount of okay. Up to now, we did the amount of energy produced across a resistance can be given by three formulas. Either you obtain it in terms of charges, that is the amount of heat energy, you can write it as Q times V, or you can write it as I square RT. You can also obtain it as V square R, V square over R times T. You can obtain it as V times I times T. Got it?
Yes, sir.
Okay, so next is electric power. Let's try to find what is electric power. So, see how do we define power? Yeah. So, power is classically we define power to be, let's say, power is the rate of doing work. The rate of doing work is called power. Or in terms of electrical power, if you want to say, so we can specify it to be the amount of electrical energy consumed the amount of electrical energy consumed per unit time, okay, is called power. So both can be called power. Either you talk in terms of energy or you talk in terms of work. In both ways, we can define we can define the amount of water. We can define the electric power. Got it? Okay. So with the formulas, let's proceed now. What are the formulas here? So we have written power to be work over time, or we got it as to be electrical energy consumed, or we can just write it to be energy consumed per unit time. Or obtain it to be energy consumed per unit time. Or we can write it energy consumed divided by time. That also we can write. Energy consumed by time. Got it? So let's obtain the formulas for power. As in the previous cases, we have obtained the formula of energy. Okay. So just dividing it by time will give us the amount of power. It can provide us power. So let's take up the formulas which we just did. We took the formula of energy consumed to be I squared RT divided by T. So you can cancel the T and T. You will get the formula of power to be I squared R. If you take the second formula to be V squared over R, multiply with T divided it by T. So you get it again V squared over R as the formula of power.
So why did we do V square over R?
That's the formula of power. That's the formula of energy. See, we got here.
Okay, sir.
The
Okay.
formula of energy, we have V squared over R times T.
Yes, sir. Understood.
Okay. So this is the second formula. You can obtain V square by R. You can obtain another formula here. See, we can obtain the formula of power to be V times I times T is the energy. And if I divide the energy by time, so I get PI. So this is the amount of electric power. So the electric power consumed or dissipated through a device can be given as V square over R. It can be given as I squared R or V times I. Got it?
Yes, sir.
Okay. So this is the electric power we got. Now let's try to do where all can we use which formulas? With some of the questions we'll see, and then we'll come to only one topic which is left, that is commercial unit of power. Okay. So let's try to solve a few questions here. Okay. Okay. So let's see this. Let's see. Okay, let's see this question. An electric iron consumes energy at a rate of 840 watt. The electric iron consumes energy at a rate of 840 watt when heating is at the maximum rate, and 360 watt when the heating is at the minimum rate. The voltage is 220 volt. What are the current and the resistance in each case? So, which formula to be used? Okay. Yes, which formula should we use?
H is equal to V square by R into T.
See, they are talking of electrical consumes energy at a rate of 840 watt. So it is the rate of consumption of energy. Okay. And also you
So
can see the
electric power.
power. Also you can see the unit is given, which is watt. Okay. I forgot to tell you that watt is the unit for power. Okay. So all of you must keep a note. I didn't tell you, just note it that the SI unit of power is watt. So there are other units also, but the SI unit is watt. In the other units, you can say a horsepower. So 1 horsepower is equal to 746 watt, which you studied in your, I think, class 9th. So see, when in the first case, let's say the first case, power is given to be 840 watt, and the voltage is given as 220 volts. First, let's try to find the current. So what will be the current here?
Sir, I think nothing.
The current, for the current, we'll use the formula. Since we know power and voltage, we want to find current, so we'll use the formula P equals to V times I. Power is 840, will be equal to voltage, which is 220, multiply current I. So you get the current I to be equal to 840 divided by 220. So 0 cancel up. You can divide it by 2. So you get 42 over 11. So current will be 42 over 11 ampere, and this will be some 3 point some amperes. So it will be 3.9 ampere. You get it, 3.9 ampere. For the second case, you have when the heating is at the minimum rate, its power is 360 watt. So I'll write here the formula of power again. Now the power is 360 watt. So I'll use the same formula to find the current. All of you use the same formula and see what is the value of current that you get.
18 by 11.
How much?
18 divided 11.
Yeah, you are getting 18 divided 11. All right.
Nearby 1.6.
Yes, sir. 18 by 11.
Okay. So you get 360 over 220, which is 18 by
Sir,
11.
1.6 ampere.
Okay. So 18 by 11, that's 1.6. I think it's not 1.4, just check it. Oh, sorry, 1.6. Yes. 1.6 ampere is the current I. Then can you find the resistance in each case? Here also find the resistance. Here also find the resistance. Use the formula of power equals to V
Sir,
square by
P
R.
square by R.
Yeah, use that formula and obtain the resistance in each case. Okay, anyone got the resistance?
Sir, 1 minute.
Rijwana Sheikh, Rijwana, Huria, you don't speak up during the classes. People don't answer any questions. Rijwana?
Yes, sir.
Okay, just tell the resistance. Are you able to get it?
I'm still doing.
Okay, do it.
Sir, for the second case, I got resistance as 134.4 ohms.
Resistance says 134 point.
4 ohms.
Okay, so you will
Second
getting
one,
it
sir.
as for
For
the
the
second
second case.
one. Okay,
Yes, sir.
V is 220, so you got 220 times 220 divided by divided by the power, which is 360. So you get 0 and 0 gets cancelled up. One of the 0 cancels, and then you can, if you divide it, you get 11, 110 over 18. Then again it's 110 over 9. So you multiply, that is 1 to 1. So 1 to 10 over 9. Is this what you got?
Yes, sir.
Okay, all right, that's correct. So similarly, you can obtain the resistance for the second case also. So these questions, they were pretty simple questions. These were pretty simple questions. You can go to this question now.
So when does this class end?
Yeah, what happened? This class, it will end at 6:50. Peak power. Okay, try this first question. You need to try question, not first, try second question. second, third.
Sir, which one, sir?
You have to try these three questions. 2, 3, and 4.
Sir, B.
Okay, in your option 2, it says that option B is the incorrect. Option B is correct since it does not represent the power.
Sir, no, sir. Option B is the incorrect, sir.
Yeah, that is incorrect. So that's why it is the correct option.
Yes.
Okay, the correct option is IR squared. That is all. There is no formula as IR squared. Okay, so this is correct. Option for the next one. For B,
So,
for
1
third
minute.
question.
Sir, we should count 220 volts or 110 volts.
Which one? Question 3.
Yes, sir.
It's given. First, it was operated at 220 volts. Then its power was 100 watt. Okay. What would be the power used when it is operated at 110 volt?
50. So, 50 watts.
50.
50 watts.
Yes, sir. 50 watts.
Okay. How did you get it?
Sir, it's a half.
Aha. Okay. Let's try to solve this. So first of all, which formula of power should we use?
P is equals to P is equals to V square by R.
Yeah, we'll use here the power is equal to V squared over R. So the initial power P1 can be written as V squared by R, where V is 220. Let this be V1. Then the final power we got P2 to be equal to V2 squared over R. If I divide both the powers, so I'll get P1 divided by P2 to be equal to V1 squared over R divided by V2 squared over R. Am I correct? Why
Yes,
I'm
sir.
finding
R.
the ratios? I don't want to find the resistance. Or otherwise, I would have done the same question in some other way also. I would have used the first power, found out the resistance, okay, and then use it. That way also I could have got. Now, for this, I will get P1 divided by P2 to be equal to V1 square over R multiplied with R divided by V2 squared. So R and R cancel and you have the power in the ratio V1 square over V2 square. So you can put the values of P1, you can put the value of V1, okay? You can put the value of V2 and then obtain and tell me what will be the power P2. Obtain it now. Using this method, obtain it.
Yes, sir.
Okay. So okay, got the answer? What the answer obtained here? P1 is 100 divided by P2
So,
equals
V1.
to
So, V1 is
V1 is
220.
220 squared. So you have 220 squared divided by 110 squared. So 100 over P2 will be equal to 2 squared. Okay. And 2 squared is 4. So
Sir,
100,
P2 is 25.
yeah, the answer is 25 watt, not the 50 watt. Got it? Okay, so try the last one. If you can do this last one, we'll solve the last one.
Sir, I think 1:2.
Okay, you think 1:2. So, okay, we'll see this question in the next class. All right. I think someone might be.
Okay,
Okay,
sir.
so bye all of you.
Thank you,
See
sir.
you by
Bye,
10.
sir.
Bye, sir.
Thank you, sir. Bye.
So just now you have your maths class or some other class?
Math class.
All right. Okay, bye.